Hello, everybody. I hope you're doing well. This is lesson number 13 in Math 100, Liberal Arts Mathematics. All right, so as we said last time, lessons 12, 13, and 14 are on chapter 5, statistics. So this is the second of the three-part series or three-lesson series on statistics. And today we'll be talking about the mean, the mode, and median, as well as a standard deviation. So this is probably the most computational of the three lessons. And so hopefully you will be able to pay close attention, and you will learn basically really what's the two things that are really important in this lesson are the mean and the standard deviation. And we'll calculate these things by hand. Of course, you can use your calculator. So get your calculator out and let's get started. All right, lesson 13 is about how to describe data sets. Right. So once you pick your sample and you collect data from the sample that you chose, hopefully a representative sample, what do you do with that data? Okay. Once when you collect a set of quantitative data. Okay, so quantitative data is the type of data that you can do some numerical calculations on, meaningful calculations. How do you characterize it, and what do you look for? All right, and so here's a good example to start our conversation with. Suppose you have a 50-point test, okay? So a test with 50 points was given in two classes, right? Class A and Class B, or you can say Section A and Section B. And the results are as follows. In Class A, the 5 students took the test, scoring 10, 20, 30, 40, and 50. Class B, or Section B, also had 5 students, and their scores are 20, 25, 30, 35, and 40. Which class or section did better? Okay, so and you say, well, you have five scores in each section, and what do you look for first? Looks like maybe B, the students did better because their lowest score was 20, right? Whereas in section A, there was a student who scored only 10 out of 50. But then you say, well, wait a minute, but in A, there was somebody who didn't miss any points. In B, the best student still got 40 or missed 10 points. Right? So there are different things that you can look for. And probably the first thing you look for is the average, right? And even this word average could mean different things to different people. It depends on which average you are using. We'll be talking about three things that represent this idea of a central tendency, like the average. But if you're talking about the numerical average, you can, this is the sum divided by the number of figures, right? Number of numbers, right? And so you, in this case, if you add up these numbers, the sum turns out to be 150, okay? If you add up these numbers, the sum turns out to be 150. So in both cases, 150 divided by 5 is 30, and 30 is the average on both sets. But clearly, there's a difference between section A and section B. So how do you define and characterize the difference between A and B? Okay. In English, you can say the scores in A are more widespread and scores in B are not so widespread. And that is a key observation that we will come back to. Okay, so how do you describe the performance of each class or each section? Okay, you can say that they have the same average. Oh, and by the way, I take these notes, and of course, I write I handwrite these things. Sometimes it's better to summarize what I am writing later, and I have a typewritten set of notes for this lesson and for the previous lesson to lesson 12 and lesson 13. You may want to look at the answer key. I have the hard copy of the worksheet, and along with that, I provide the set of notes. These are the first 2 pages of the answer key are these lecture notes, and there you will see these notes nicely typed up. So you may want to take a look at those things also. All right. Anyway, these 2 classes or the 2 periods or the 2 sections, A and B, have the same average. Okay, but A is more widespread. You could say more diverse, more variation. And so we will be talking about how you measure variation in the second half of this lesson. Okay, so how do you describe the central tendency? Like what, is the average person like, and what's the average? It depends on what we mean by the average. And so you may have seen these, like many high school math classes now teach these things, the mean, the median, and the mode. Okay, let's review these if you have seen them before. If you haven't, that's okay. The mean is what we normally call the average, the numerical average. You add up all the numbers, the sum of all the values, and then you divide it by how many values you have, or the sample size. In this case, the sample size was 5, right? There were 5 in each sample set. And so you divide the sum 150 by 5. And we found out in both of these sections, A and B, the average, or the numerical average, the mean was 30. The median, on the other hand, is the middle value when you when these values are ordered in an ascending or descending order. Okay, so make sure you order them first, and then you take the middle value. Now, sometimes the middle value is not found. Let's say you had 6 values here, written from the highest to the lowest. Well, there is no middle value here because you have an even number of values or numbers. And so in that case, you take the 2 middle ones, okay, and take the average, or take the mean of the 2 middle values, and that would be called the median. All right, the median is particularly useful in certain things. Like, for instance, if you are in the real estate business, let's say, what is the typical home? How much is a typical home in the Santa Clarita Valley or something? Well, instead of the mean, many people use the median, and there's a reason for it. Okay, and we'll talk about that in just a minute. All right. The mode, on the other hand, is the most frequently occurring value. All right. And sometimes there is none. Okay. In these cases, A and B, every number is distinct, right? Every number in A is different from each other. Every number in B is different from the other ones. So there is no mode. But if one number happens more frequently than any other numbers, that is called the mode. Okay, so let's practice. We find all 3 of these for this. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 values here. Yes, it said that too. Okay, and are they ordered from the highest to the lowest, or the other way around? It looks like it is going from the highest to the lowest, right? And so let's take a look. In this case, how do you find the mean? Okay, well, you have to add up all the numbers in here. Okay, so the sum of all of these numbers. All right, so what you have to do is to add 60 plus 57 plus 53 plus 53 plus 53 plus, and so on until the end. Okay, and if you add them up, the total is going to be 492. Okay, I encourage you, strongly encourage you, to take your calculator out and add up all of these 10 numbers, and you'll find that the sum is 492. All right, so that means the mean is going to be 492 divided by, remember you have 10 values, right? So this will be 49.2, and that is the mean for this data set. Okay, remember you're supposed to find all 3 of these. So the first one is the mean. All right, what is the median? Now notice here we have 10, that's an even number of values. All right, so you have 1, 2, 3, 4, 5, and 6. Between 5 and 6 right here is the middle. So there is no one middle number. So in that case, what you will do is to take the 2 middle values, the 5th and the 6th. Right? Remember, because you have 5 below this and 5 above that. So you take 53 plus 49 and you divide it by 2. So this will be technically the mean of the 2 middle numbers, right? And so when you do that, you get 51, and 51 is your median. All right, how about the mode? The mode is the most frequently occurring number, and in this case, you have 53 occurring 3 times. No other numbers occur 3 times. 40 occurs twice, but 53 is the mode because that happens to appear more than any other numbers, or more frequently than any other numbers. Okay, so that's pretty easy, right? I mean, to find the mean, the median, and the mode. Pretty simple task, I think. All right, now, one thing you have to be careful about in calculating the mean is that sometimes you have an outlier or outliers that could affect the mean tremendously, or influence the mean, or um, yeah, basically strongly affect the mean in a tremendous way. And so that's called an outlier. What is an outlier? It's a data value which is much higher or much lower than most other values. Okay, and they highly influence one of these, especially this one, the mean. Okay, so here are some examples here. Let's see in this example, 5 people. You go to, let's say you go to, the corner of Hollywood and Highland. You know that place? Always busy, right? Even during a pandemic. And so, you just ask 5 people on the street. This is the convenience sampling. Um, you ask the 5 people the first 5 people you meet up on the street there, and you say, hey, how much did you make last year? Okay. And let's say 4 of these people didn't have a job. Okay. And the fifth one you saw happens to be an actor, okay? I mean, that's what you see in Hollywood, right? So the first 4 says, no, I didn't make any money. I didn't make any money. I made $0. I made $0, right? And then the last one says, oh yeah, I made about 5 million last year. Okay, what's the average of these? Well, the average of these is the sum, which is 5 million, plus 0, plus 0, plus 0, plus 0, divided by 5 because you asked 5 people. And so it turns out the median, or not the median, the mean of the 5 numbers that you found turns out to be 1 million. So can you say on the average, based on these 5 people, the average is $1 million per person? Well, you could, and that would be a correct statement, but that's very misleading, right? Because 4 of these people didn't make any money. So in that situation, or in this sense, the mean could be deceptive or misleading. And so the mean may not be a good measure of central tendency if you have an outlier like this. Okay. Basically, this one number is changing things tremendously. If this person wasn't there, the average would be 0. But because of this one outlier, the mean turns out to be 1 million. All right, so that would be a problem. Now, here's another example. So this actually happened, I don't know, back in the 1980s. All right, so a survey was done, I think, by the American Geographical Society. What college or what university had the highest average among highest average first year salary among the graduates in the geography majors? Now, how many geography majors do you know? But there are people who major in geography, okay, and somehow they find jobs, and some of them do well, okay. So the American Geographical Society was looking for the best, or the ranking of the best universities in the measure of geography, and the measure they used was, the highest average first year salary among the students who graduated with a degree in geography. And in one year, a particular year, 1986, they found out that the University of North Carolina in Chapel Hill had the highest average salary among the geography majors. When they're, basically, let's say there were like 20 students who graduated from, major in geography, and how much are they making in their first year? You find the average for each school. University of North Carolina not only was the first, they were way, way ahead of everybody else, okay? Why in the world did this happen? Okay, 2 words, okay? They had one graduate who actually graduated with a geography major. His name was Michael, what? Jordan. Okay, so Michael Jordan actually graduated and got a degree in geography from the University of North Carolina, Chapel Hill in 1986. And his first year salary was tremendously high. I don't know exactly how much the Chicago Bulls paid him, but he made tons of money in that first year. And that was the outlier, right? So, but again, the statement I just made, I mean, the statement that's expressed here, the University of North Carolina did have the highest average first year salary among the geography majors in 1986. That is a correct statement. It's very misleading, right? Especially because this one person did not make money out of geography. Just he was paid by the NBA. But is this a good measure? Right? So the point is, be aware of outliers. Okay, outliers could change the mean value tremendously. All right, so for the average, people don't use the mean all the time. So the average home price, household income, and so on, Many people use the median. Okay, so why is it, right? So look at the median in this case here, 0.00005 million, all right? The median is the middle number here, which is 0, which is a pretty good representation, right? I mean, except for this one person, almost everybody here made $0. And so the median is often used. And the reason is that the median is not significantly affected by outliers. All right, so let's see, I'm trying to make a little visual aid, a graph of, how much, let's say, the home prices are, okay? How much are the homes in the area where you live, okay? Some homes may be fairly reasonable, like maybe $100,000. If you can find a house, a nice home for $100,000, let me know. And then maybe 200,000, 300,000, 400,000, and then you have $1 million homes here, and then $2 million homes here, right? And then if you have the tabulation, like how many homes are there, and each of these dots represent a new home or a home for sale in that range, in the price range, and so there are probably a lot more here, and but anyway, so there are some extremely expensive homes in whatever the area you live in, okay? So maybe you have 3 homes that are like millions of dollars, okay? These are 3 outliers, right? And so what happens here is that maybe the median home, okay, if you, again, list all the home prices from the lowest to the highest, the median may be right here, okay? Well, what happens if you add these 3, or if you don't have these 3, okay? If you remove these 3, the median will shift by 1 or 2 of these, but the amount is not going to change very much, right? Whereas the average may be greatly influenced by these homes. Let's say these homes are like not just 2 or 3 million, maybe 50 million or $75 million or something. And if you have 3 of these homes, the average number will change significantly, but not the median, okay? And that's why often the median is the choice for measuring the central tendency in the data set, okay? So outliers could affect the mean number in a very significant way. All right, now on the second page of these lecture note pages, let's look at the measures of variations. All right, we'll just do 2, and one is much more important than the other. Okay, so we'll study 2 measures of variation. The first one is called the range. Very simple. The range is the maximum value minus the minimum value. Okay, what does it tell you? Well, it tells you how spread out the data set is. Let's go back to the first example we did. Okay, back here, the section A had the lowest number of 10 and highest of 50, right? So the range in this case is 50 minus 10, which is 40. You could basically say that the test score or test scores ranged from 10 to 50, which is the range of 40. Over here, it's 40 and 20, right? Highest was 40 and lowest was 20. So you can say the range here is 20. And you can say, I mean, it's clear that the smaller the range is, the less spread out the values are, okay? So if you take the highest number, subtract, minus the lowest number, maximum minus the minimum, that range does tell you something about how spread out the data set is. So that is a fairly, well, it's an okay measure of variation. Okay. But again, if you have like one outlier, maybe 2 outliers, one extremely high, one extremely low, and everybody else is like sort of in between right here, then these 2 values could significantly alter the range, right? And so maybe it is not the best way to describe the spread or the variation. So the second one, this is by far the more important of the 2. And this is called the standard deviation. All right, this number is extremely important, all right? In fact, it's so important that basically in any statistical study, right, you can't really be talking about this without the standard deviation. And by the way, this number also plays a major role, not only in this lesson, but in the next lesson. So let's try to figure out how to obtain the standard deviation. We will abbreviate this as SD, the standard deviation. Actually, there are two versions of this. We'll just focus on one called the sample standard deviation. Of course, because many times in reality or in applications we have to deal with large data set. This kind of calculation is done by a computer or a program. Excel has a very nice way of doing this, all right? But for at least once, you will have to calculate this by hand so you can feel what the standard deviation is measuring, right? So how to calculate the standard deviation? This is the second part of this lesson, all right? Standard deviation, how do you calculate it, all right? And I will show you how to do that by hand. And once you learn it by hand, then you can let your calculator or computer program to do this for you. But I will have to teach you how to do this once by hand. So that's in the second part of this lesson.